Back. Alright, I got my new setup now. I had this old, I bought this Voyo Mini that we're using at the office, and the thing just wasn't powerful enough to stream stuff, and I had this cheap mic that was highly rated on Amazon, but apparently it sounds like I'm drowning in water or something like that, so I got my old setup back. And hopefully these videos will be more abundant, and there'll be more of them. So that same thing. Okay, I got a 6 Plus here with no power. It's drawing 1.1 amps on the ammeter. Before I do anything, let's plug this sucker into the DC power supply, and let's see what happens. All right, so I got a 6 Plus. I got it right here, 6 Plus connector. So DC power supply thing, you really want to, I don't know if you can see it or not, but can you see it? You really want to use one of these little power things, because if you use those little cheap ones that doesn't have this thing in the middle, it's not going to power on your phone, man. I found out the hard way for a long time. So we sell them at our store. It's $24.99. I think we discounted it. So you can just go to the store and buy it. This will power on your iPhone, okay? So charge dock, batteries connected. I set my DC power supply to 4.1 volts, and the amps will adjust based on consumption. So you're going to need to plug in a lightning connector to prompt it to boot, or you can just whatever short these pins up here. I don't know which ones they are. I don't do it because I don't remember. So I'm going to plug it in, unplug it, and we are at 0.12. 0.18, 0.19, 0.75, 0.20. Looks like it's actually kind of booting, actually. So this is at 1 amp now. So let's do this, okay? Let's put a screen on here and let's see what happens. Did you plug it into iTunes at all? Nothing? Nothing. Okay, so no iTunes recognition. No display, right? No display? No backlight, no display. No nothing, says Sanjeev. No backlight, no display, no nothing. I'd like to see for myself, man. Alright, so we got the screen hooked up now. Clean this screen up. See if I can see anything. Prompt to boot. And we got nothing. Oh, hold up. It's not really booted. Something's not right. Okay. So it's a 0.47 on the ammeter. Or the DC power supply, I mean. No image. Actually, I do see a little bit of something, actually. There's something. It's like lines up and down. Yeah, something's, the screen's like trying to power on and stuff. So we got some issues with something. Maybe chestnut. So looks like it's booting though. Let me plug it into the computer. Let's see if that recognizes it or not. Oh, boom! It recognizes it, man. You lied to me, man. You lied. Yep. Okay, so this is a display problem. This is a display problem, man. iTunes is all good, I think. Maybe. Unless this battery connector just died again. Yeah, it's good, man. Alright, so this is a display issue, and I saw some lines going up and down it. So I'd probably have to say chestnut. So let's do this, okay? Let's take a look at the board. Okay, so we're looking at the board. It doesn't look like, 6 Plus, you always have to assume that maybe touch IC issue or something like that, but this is never been worked on right here. So next step is let's check the display lines in diode mode and see if we can find something juicy. Alright, so display lines, alright? We've been through this before, but what is required for the display to power on? You got PP1V8 LCM, which is this top left pin. So that's at 0.28. So what I like doing is I like shorting this sucker first, and then just to ground it, just to zap any of the capacitors. You know, just make sure the caps are discharged, because the diode modes can be affected by charged caps. So let's go back and measure it again. We're at 0.31. That looks pretty good. I mean, that looks fine. And then we got the P. I think this is PN5V7, power negative 5V7. This is 1.31, and this is power positive 5.7, which is 0.58. Okay, they all look pretty good. And then we skip down to so we skip down to 8, 9, and 10, which are I don't know what order it's in, but I think 8 is the LCM enable line. One of these is the reset line, and then the last one is the B-Sync line. So they all test pretty good. Actually, let's see. B-Sync line. So it's 0.48, 0.48, 0.75. I think that's okay. I think that's okay. So I'm gonna check the B-Sync line again. 0.47. Okay, that's the same on this side. So I think we just have to assume chestnut at this point. Can we confirm? Well, let's do this first. All right, let's desolder the shield first. So desoldering the shield, it's not really a science. Here's what I do. I take my, you see it? I just take my quick 957 DW, take the tip off, and I use this solely for removing shields. And I'm gonna get my heavy duty tweezers here, and basically just blast it. I mean, it takes about 2 seconds to pop it off, man. So if you have problems taking off shields, maybe 10 seconds. There you go. And we are done. See that? Easy. Alright, so we have it off now. Let's get all this little black stuff will get off your fingers and stuff, so I like to just wipe it and just chuck it. So let's inspect. All right. Okay. So where's chestnut? Chestnut is the one that is the chip that's preceded by TI. So you see that TI? You can barely see it, but it's this way right here. This is called chestnut, and this chestnut is pretty much the same across I think going up from the 5C all the way up, they all use chestnut. So looking at it, my guess is probably chestnut is just not good. That's my guess. All right. Probably. Let's see. Dang it! I'm trying to get. All right. I'm trying to. So before we lift chestnut, I mean, lifting chestnut and just replacing it would probably be the easiest. But let's see if we can diagnose this before we actually. So we have a 5V1 here, which it's in the corner of the chestnut. You'll see it. So this is chestnut right here, and that's 5V1 right there. Okay, so this often gets corroded. Okay, along with these two. For some reason, I don't know why, but this often gets corroded. So let's do this. All right, let's measure diode mode on this PP5V1 line, and I'm gonna get a reading because so when you measure diode mode, right, it basically measures the voltage drop on the line from whatever point it is to ground. Okay, so the only thing that's going to really show a voltage drop is really a diode or a transistor, for the most part. And then these diodes and transistors are built into these chips. So if there's a chip in that line, then you're gonna get diode mode. So even if this is corroded, we're still gonna get diode mode because this 5v1 line is connected to Mason. All right. So, but what we can do is we can compare. So we can compare. Why is it so dark, man? Is that better? Alright, so let's just measure this. .54. So let's just measure it with one of our boards here, and let's see if we get .54 or not. So that's going to tell us if it's corroded under that pin. Maybe. If I can find a logic board here that works for me. I need, every time I'm looking for a logic board, 6+ logic board, I can't find one. I need one that's intact. Dang it. No 6+ logic boards that are intact. Awesome. Dang it. Are you working on anything right now? Do you have anything up there? Do you have a logic board up there, 6+ logic board? Yeah. Yeah, but those have chips all removed from them and stuff. Alright, let me see if I can find one real quick. Let me pause it. Alright, I have a donor board here with seamless still on it. So we can assume that that 5 line is 5.1 line. So oh, can't even hear me. Okay, anyways, I said 5.1 volt line looks pretty good because I just measured it on a donor board and it was the same. So what do we do from here? I mean, I guess if we really want to diagnose it before we fix it, what we can do is just hook up. So I have this little connector here that I use. It's a flex connector. You see it? It's an extension connector. And basically I just kind of scraped it off right here. And then that way I can measure the voltages, So that's what I'm going to do, okay? Unfortunately, I should label them because I don't know what is what now. Like, I don't know what these pins are. So what you do is you hook it up, put the screen on it, you plug in the battery connector, power this mother on. Okay, so now it's powering on, I think. Yep, it's powering on. I see the DC power supply is moving. And then we just measure voltages and see which one we're missing. So I got 1.8 volts. So this must be backlight up here. Getting 5.9. Oh shit, I just poked a hole in that. Oh, that's not good. That sucks. Hopefully I didn't just destroy that. 1.8 volts. So I think these are the 5.7 volt lines here, maybe. And I'm getting 0 for that. So now I'm uncertain about this because this trace is broken. 4.1. Well, on my extension cable it is. And then I don't know which ones are the 5. I think these are the 5.7 volt lines right here, and I'm getting 0 on them. So this is 1.8, right? This is 1.8 constant. So this is LCM. This is the LCM enable line. So I'm assuming that these should be the 5v7 lines. And then let's see, 4, 5, 6, 7, 8. Okay, so 8 is the LCM enable, and that's 0. They're all 0 volts. So let me try plugging it in again and see what they. Oh, there it goes. I see a screen now. So I got an image, but look, it's got lines on them. Interesting. What's up? It's rebooting now. Look at that. How did that happen? What is that? Why does it have lines like that? Like, what is this, man? Is that a connector problem, or what is it? Something's definitely getting hot here. Oh yeah, something's getting burning up here, man. It smells like chestnut that's burning up. Man, this is burning up. Yeah, I think his name is Chestnut. So touch doesn't work. And Chestnut's burning up. So I think he's going to have multiple issues. Well, you know what? It's probably just Chestnut. Right? Alright, I don't think I'm going to go any further on this. I think what I'm going to do is just replace Chestnut and see what happens. I told him like 80 bucks already, so. Oh, did I just say that on camera? I meant 135. Now this is a local repair guy, and we normally do a little bit less because they walk in here and they drop it off and then they come pick it up. So not a big deal. We'll know for certain, you know, as soon as we remove this, I think we'll know. I mean, it's probably, well, I would say Chestnut first, and then I would probably say maybe Touch IC issue after that. So if it's both, then man, we might have some issues in terms of cost. So you can immediately see right there that, look at it, okay? Remember how I was saying that there's corrosion? Oh, you can't even see it. Dang it. Sorry about that. Alright, so remember I was saying about corrosion on the sage joints and PP5V1? You can see right here that this is corroded right here, and this is also corroded. See that? I didn't do anything. So that's why touch doesn't work. So you think it's probably a touch IC problem, which we may end up having to probably replace anyways. But the touch problem is unrelated to M1 and U2402. It has to do with these two joints right here. And let's see if there's anything else that's missing. I'm just going to kind of nudge just a little bit, see if something comes up. Nope, looks like everything else is good. So what I'm going to do is I'm just going to put some flux on it and get the old stuff off, and then see if I can make this a little more clear for you guys. Dang. It's like clearer if I go like this. Alright, that's fine. So let's clean house on this. So I'm just going to kind of get the old stuff away, and let's see if there's any other corroded joints while I'm doing it. Maybe a little bit there, but nothing bad. And that's really it. So it's just those two joints. But that doesn't really explain the the lines on the screen and stuff like that. Unless maybe Chestnut was also bad. So I'm actually going to wick this stuff because I don't like leaving, for some reason on Chestnut, I don't like leaving the old stuff on here because it really ever sits well, man. So I'm just going to get the old stuff off. Okay, so that's good. I'm curious what's going to happen because, a lot of what we fix now are 6 plus, 6S, 6S plus. Not a whole lot of 7 pluses, but, at some point, like the 5S and the 5 series, those phones are going to stop being repaired, at some point, I think. And, what happens to microsoldering, right? When the bulk of your business goes away. It's going to be a gradual one. That's, I think, a question that if you're in this business, you should probably be thinking of. Alright. So let's replace Chestnut and hopefully everything is good. I'm not going to reuse it because it was already getting hot. Chestnut here. I'm pretty sure the orientation is A1. Okay, so we are good. Let's flux it a little bit more. Still not really satisfied with this. It's still, I should be able to kind of push it a little bit. There it goes. Alright, so we are good to go here. Let's wait for it to cool down a little bit. And basically just, this is kind of shiny right now, so I'm just going to wait for that to kind of solidify, and then I'll put some IPA on it to wash it off. Alright, so that's it. Alright, so let's make sure we don't have any shorts or anything. So let's diode mode it. 0.3 OL 0.56. Okay. Everything tested good, so let's power it up again, see what happens. You know what? I got an image, a good image, and it's booting. No, it's booting. So that's a good sign, but I cannot confirm whether it's fixed or not yet. Touch is working. So I guess the question is, do we replace Touch IC on it or not? I'd say probably no. Do we have a passcode for this? We do, right? I think we do. I think it's the first one where I told you, remember? Definitely need a little bit of lotion. Look at these. Oh, that's hurting. All right, so we are in business, I think. Oh man, that's an inappropriate picture right there. Sorry about that, guys. For all the kids watching, I apologize. All right, so I think we're back in business, guys. All right. I don't normally spend this much time troubleshooting these things, really. I mean, if I suspect chestnut, easiest thing, right, is just go in there to replace chestnut, right? Replacing chestnut is fairly simple. But if you want to figure out why things are happening, then this is what you kind of have to do in order to fix these things, you know. And So I like figuring out why. Sometimes, sometimes I just want to get it done. Especially if I'm busy. So, but anyways, this is step-by-step process on how to troubleshoot something like this. So there you go. All right. Thanks for watching. I am very, very close to about 10,000 subscribers on YouTube. I think I'm probably like 60 away or something like that. So if you like this video, please share it. We got some courses out there that I'm gonna plug. We have a basics course, common repairs course, and a data recovery course, and we're going to try to add some more stuff to it because the feedback that our courses are driven by feedback, and the feedback that we've gotten is that it's kind of missing a few things. So we are here to make it better, and we're going to make it better. And if you're interested in learning microsoldering, go to our website, microsoldering.com, click on store, and there are links there to get these courses. We are selling these courses for $50 this month each, and I don't know if we're going to extend it or not into the new year. We might, but if you want to get it today or tomorrow or Sunday, because the price may or may not change after that. I'm not sure yet. Anyways, I hope you enjoyed this video. Let's see if we can get me to 10,000 subscribers, and take care.